Hello everyone, welcome to today's class. In today's class, we are going to look at binary operation. Binary operation. Now, whenever I introduce this class to as a new topic to my students, they always think that it has something to do with binary numbers. No, binary. The word binary means that something are in twos, okay? So binary operation means that carrying an operation in twos. What does that mean? Even if I have three operations, I will keep taking them two, two, two. So that's what we are going to see here. Now, what is binary operation? Binary operation is the rule of combination of two or more elements, okay? The rule of combination of two or more elements in a set, in a particular set, okay? What does that mean? You don't have to bring this set and bring this set and combine the elements in those sets. No. In binary operation, you look at a particular set and carry out a combination of two or more elements in that particular set. Now, let us write the definition of binary operation. Now, you can see the definition. Binary operation is the rule of combination of two elements in a given set. Okay, in a given set. So if I have a set, let's say a set A, which will give me, let's say X, Y, W, E. Okay, this is a set A. Now, what is the rule of combination? Which rule am I going to use to combine any of these two elements? That is binary operation. Okay, rule of combination of two elements in a given set. Now, this rule of combination, you don't need to start thinking, how are you going to get the rules of combination of two elements in a particular set? No, because the rule of combination of any given two elements in a particular set will be given to you. What does that mean? For example, you can be told that in this set, X binary Y will give you X plus Y. You can see that you have been given the rule of combination of these two elements in the set A. Of course, X and Y are elements of set A. Okay, are elements of set A. So you will be given the rule of combination. So if you are given the rule of combination, you have to obey the rule of combination in any operation you are going to carry out under that particular question. I hope you are following what I'm saying. So you'll be given rule of combination, you just have to follow it. Now, the sign you are seeing here, we mostly use this. We can use this. We can use this. We can use this to represent our binary operation. So whenever we have any of these signs, we have more. We can use more, okay, to represent that X and Y are combined on a particular rule of combination. And if you are given a rule of combination, you follow it and find your answer or carry out your operation. Let's take an example. If X binary Y equals to 2X plus 3Y, find 3 binary 4. Now look at the example we have there. X binary Y equals to 2X plus 3Y. You can see that the rule of combination here is not the rule of combination here. So whenever you are given the rule of combination, you follow it. Okay, you follow it and solve your problem, carry out your operation. So the rule of combination of X and Y is that 2 times X plus 3 times Y. Now, what I normally tell students is that don't just see it as X and Y, see it as the first number and the second number. So the first number times 2 plus the second number times 3. You get your answer, as simple as that. So that will give you 3 binary 4 equals to, obeying this rule of combination of these two elements, that will give me 2 into 3. You can see our first element plus 3 into 4. You can see our second element. That will give us 6 plus 12. That will give us 18. So we are done. As simple as that. So binary operation is the what? Is the rule of combination of two elements in a given set. So you can also be asked to, let's put this one as I, have I. You can be asked to find 1/2 binary minus 5. The same way. So this one become our I. You take the same way, 1/2 binary minus 5. This become the first element, while this become the what? Second element. So that will give us 2 into 1/2 plus 3 into minus 5. So this will give you 1. This will give you minus 15. So that will give you minus 14. So you are done. You can see how simple that is. Okay, so carry out your binary operation on any two given set elements. It's very simple. Just obey the rule of combination and carry out your operation. So it's as simple as that. So in the next thing we are going to look at is closure property. Now, in binary operation, there is need for closure. Okay, you don't just, like I said in the introduction of the topic, you don't just pick element from this set, element from that set, and you are carrying out rule of combination. No. Okay, it must, from the definition, it must be in a given set. So that gives it, there's a boundary, or there's this clause that it must be within a particular set. Okay, of course, this example does not specify whether we are taking it from a particular set or not, but sometimes you'll be given a problem and you ask to find whether it is closed, okay, within a particular set. So we are going to look at closure property. This property bound every problem or every other laws under binary operation. So let's look at that now. So we are going to look at closure property. Now, what do we mean by closure property? Like I said before, closure property is a kind of clause that is holding every law in binary operation. So what is closure property then? If A binary B gives you C and A, B is element of set S, therefore the operation is closed if C is element of X. Now let me explain that. If I carry out a rule of combination between two elements A and B, and I get another element C, and I know that A and B belongs to a set X, the operation is closed if the element, the third element that I got as my answer, is also an element of what? Set X. So what does that mean? It simply means that whenever you carry out your binary operation, your answer must belong to the same set from the two elements that you have combined. When we are talking about the same set, we are just talking about the same number set. For example, the same real number, integers, rational number, irrational number, etc. So if I say that 1 and 2 are elements of an integer, and I now carry out an operation, okay, which is under a rule of combination, and I got the third element, let's say minus 1/3. The question is that, is minus 1/3 also an element of an integer? No. Hence, the operation, the binary operation is not closed under the given set. Okay? Now let us look at two elements, or let us look at two combinations that are closed. Okay? So show, we're going to have show if the operation is closed. Number one, 2 element of an integer. Okay, so this is the sign we use for integers. So 1 and 2 elements of integer. Okay, let's first of all have the, okay, show if the operation is closed. A binary B equals to A over B. Number one, 1 binary 2 if 1 and 2 elements of an integer. Then number 2, 1 binary 2 if 1 and 2 elements of a real number. Okay, so we are going to look at this. If we take 1 and 2 as elements of an integer, and we take 1 and 2 elements of a real number, let's see whether these two sets are going to be closed under this binary operation. Okay, so let's take solution. Let's take number 1 first. Now, what are they saying? 1 and 2, they belongs to a set of integers. Okay, so if you carry out this operation or this rule of combination on 1 and 2, will the answer also give me an integer? So let us find out. 1 binary 2 will give us the first element is A, which is 1 over 2. And 1 and 2 are elements of integer, but 1 over 2 is not an element of integer. Therefore, the operation is not closed under the set of integers. So you can see that in this case, I pick 1 and 2 from the set of integers. I carry out my rule of combination. It gave me a third element, which is 1 over 2. And 1 over 2 is not an integer. Therefore, the operation is not the operation we're supposed to indicate the operation. The operation is not closed on the set of what? The integers. Okay, so let us look at number 2 and see if it will be closed under the set of real numbers. So number 2 now, we have 1 binary 2 equals to 1 over 2. Okay, 1 and 2 are elements of a real number, and 1 over 2 is also 1 over 2 is also a real number. Therefore, the operation is closed under the set of real numbers. So you can see the difference between the two answers. The first one, we are looking at integer. A fraction is not an integer, so it's not closed. Okay, and the second one is actually closed under a real number. Now, some might be asking, what if we obey this? If we have, let's say, 4 over 2, that 4 over 2 will give us 2, and 2 is an integer. But the truth is that if there is if there's any case that will give us something that is not an integer, therefore it's not closed. So even if millions of answers will give me an integer, but just one answer will not give me an integer, it simply means that it's not closed. So if there's any one that deviates from being an integer, it's not closed. It simply means that that operation entirely is not closed under the set of integers. Okay, so this closure property is like a bound on binary operation. Okay, though most of the question will not tell you the set. Of course, most of the question they will tell you under array number. That's because they just don't want you to start working on closure property. But if they talk about under an integer and there is any element that I can pick that will not give me an integer, it simply means that that problem entirely is not closed. Now, having done that, the closure property, let us look at laws of binary operation. There are So the first law we are going to look at is commutative law. Now, what do we mean by commutative law? Remember, the previous property or the previous thing that we did now is closure property. The closure bound on every law. So before a law, we can investigate whether this law is true or not. It must be what? Closed. So let us try something on that. Okay, so you can see the little introduction there. Given that the operation, that's the binary operation, is closed, if A binary B is equals to B binary A, then the operation, that's the binary operation, is cumulative under the given set. So this one is very simple. All you need to do is that when you interchange these elements, will it still give you the same thing? If it's going to give you the same thing, then we say that the operation is what? Commutative. Okay, we say that the operation is commutative. Let's take some examples and see where we have commutative property and where we don't have commutative property. Okay, so we want to show whether this operation, oh, this operation is commutative. So let us see or use it to explain commutative law. So if we have, looking at number one, if we have x binary y equals to x squared plus y squared, and we have y binary x, that will give you y squared plus x squared. Remember, the first one, the rule of combination given to us is that the first one x squared, the second one comes second. So the first one here is coming first, the second one is coming second. Okay, now these two things, are they the same? X squared plus y squared, is it the same thing with y squared plus x squared? Since x squared plus y squared is the same thing with y squared plus x squared, therefore the operation is commutative under the given set. Under the given set. Okay, so let us look at the second one. If I have x binary y as 3x minus 2y, and I have that y binary x equals to 3y minus 2x. So 3x minus 2y and 3y minus 2x, are they the same? I don't think so. 3x minus 2y is not equal to 3y minus 2x. Therefore, the operation is not commutative under the given set. So that's what we mean by commutative law under the given set. So you can see that the operation is not commutative. Okay, we can actually use numbers to show that. You can have a binary operation and you are asked to show if the operation is commutative. You can decide to use numbers. Numbers, we actually, sometimes there are some numbers you use, it not look as if they are the same, but if you be able to use numbers that are distinct, you'll find out that it will not be the same. Okay, so they can give you any form of operation to find if they are commutative or not. All you need to do, you can pick numbers, but when you're picking numbers, please don't go and pick 0 and 0. Just pick a good number, probably like 3 and 5. So you put it in your expression and find out whether it will be the same. If it's not the same, then it's not commutative. Okay, so let us look at the second law of binary operation. So our number 2 law is associative law. And this associative law, of course, it have to be closed. The operation have to be closed. Then if you look at this, right, like I said earlier, that binary operation means combining two elements. Okay, so you can see we have 3 elements here, A, B, C, but we have to take it 2 at a time. Okay, so if I have A binary, open bracket, B binary C, and it gives me A binary B, open bracket, close bracket, binary C, then the operation is said to be what? Associative under the given set. Now, what does that mean? If I have a bracket and I shift this bracket to combine these two first, instead of the last two, I combine the first two, then have the last element, and they are still the same. Then we say that it's associative. Okay, we say that it's associative. Now, let's take one example. If they are not associative, you're definitely going to know. Like I said, you can test with numbers. You can actually solve without using any number. That's using algebraically. You'll get your answer. So let us see an operation and check whether it's associative or not. So in this problem now, look at the rule of combination given to us. A binary B equals to A plus B plus 2AB. So we are going to include the third element, okay, which is C, to be sure that if we do that, it's going to give us our answer. So we have this to show associative law. A binary B binary C will give us the same thing with A binary B, then binary C. So let us take it here. We take it gradually. Okay, it takes a little longer than the commutative law. So we take it gradually. So first of all, take care of this. So B binary C, obeying this rule of combination, the first plus the second plus 2 times the first and second. So that will give us B plus C plus 2BC. Okay, now we have gotten this. Now let us include A binary. So this is our left hand side. A binary B binary C. That will give us A binary open bracket. B binary C gave us B plus C plus 2BC. Okay, so we are going to carry out this operation obeying this rule of combination. It's very simple. The first one is A plus, the second one is B. So our second term element here is B plus C plus 2BC. So that will give us B plus C plus 2BC plus 2. The first element, our first element here is A. Our second element here is B. That's okay. We are using this one now. Our second element here is B plus C plus 2BC. Okay, so we are going to, this is our left hand side. After that, we'll check our right hand side and see if they are the same. So let's open this bracket. That will give us A plus B plus C plus 2BC plus 2AB. That's, I'm opening this bracket now, plus 2AC plus 2ABC. Okay, there's no like term to collect there. So this is our left hand side. So we need to look at our right hand side now to see if we are going to have the same thing. Okay, so let's look at our right hand side. Underneath our right hand side, so for right hand side, we have to first of all look at A binary B. So A binary B will give us, obeying the rule of combination, the first term binary the second term will give us the first term plus the second term plus the plus 2 of the first term and the second term. So that will give us A plus B plus 2AB. So we have gotten our bracket. So the next thing now is that A binary B binary C equals to, we have already gotten this one as A plus B plus 2AB binary, the third term, which is what? C. So obeying this rule of combination, we have it that the first term, which is A plus B plus 2AB, okay, plus our second term here is C, plus 2 of our first term, A plus B plus 2AB, then times our second term, which is what? C. So we open this bracket, we have A plus B plus 2AB plus C plus 2AC plus 2BC plus 2. Oh, this one here, 2A times 2BC is supposed to give us 4BABC. So doing that also here, 2 times this will give us 4 times C will give us 4ABC. So let us rearrange it and see. We can actually indicate, we can actually use something to indicate, to show that they are the same. We have A here, we have A here, we have B here, we have B here, we have C here, we have C here. Okay, so these are the single numbers. Then let's look at the numbers that are double. So we have 2BC, we have 2BC, yes, we have 2BC here, we have 2AB, we have 2AB, yes, we have 2AB here, we have 2AC, we have 2AC. Okay, then the last one, we have 4ABC, we have 4ABC. So since, oh, let us clean this part and conclude there. Since A binary B binary C is equals to A binary B binary C, therefore the operation is associative under the given set. Okay, so in a situation that you have treated the left hand side and is different from the right hand side, it simply means that the operation is not associative. Okay, so let's look at distributive property, which is the third law of binary operation. In distributive law, uh, they hardly ask distributive law in secondary school level because of the complexity of the law. Okay, but I'm going to briefly explain it. Probably we'll make another video where we can be able to solve examples under distributive law. You can see how look how the associative law is looking like, but the distributive law is actually going to take a longer time than the associative law. Now, what we mean by distributive law? Distributive law, we are going to have two binary operations. That means we're going to have two different rules of combination. Now, we now check if this operation is going to distribute over this one, or if this one is going to distribute over this one. Okay, so when such happens, we say that the operation this distributes over this under a given set. Like I said, that in distributive law, we have more than one binary operation. So look at this. We have A binary, open bracket, B binary, C. So you have A, just like when you have multiplication and addition. So you have A times B, then plus A times C. So that's how it looks like. Okay. So if what you have here is exactly what you have here, then we now say that the first binary is distribute over the one in the bracket. Okay, and that's not all, because we can also have uh left distribution and right distribution. So this one now is what we call left distribution. Why is it left distribution? You can see that what is outside the bracket is on the left hand side. So if this thing here is here, which is on the right hand side, you will notice that we have B binary A, C binary A. So in such case, we say that is right distribution. Okay, so we are just going to solve a small example on this using numbers, because it's only numbers that that will look a little bit simple, because when you want to use algebra to do this, it's going to take a lot of time. Okay, so let's have example of this, then we use number and they solve it and find out whether it distributes over the other. Okay, so look at this example. It's a very simple example. We can even solve using algebra, or we can solve using numbers. It's a very simple example. So we have that A binary. So this particular binary is multiplication, while this particular binary is division. So we want to know whether this binary distributes over this. So we are to show that X binary, Y binary, Z will give us X binary, Y binary, X binary, Z. Okay, so this is what we need to show. So this is our left hand side and this is our right hand side. So we are going to do the left hand side and do the right hand side and check our answers whether they are the same. So on the left hand side now, we first of all take care of the bracket, which is Y binary Z. Y binary Z will give us Y over Z. Okay, and combining the outside the bracket, which is X binary, Y binary, Z. So that will give us X binary, This is our y binary z, so that will give you y over z. So when you combine this with this, obeying the rule of combination of asterisks, that will give us x times y over z, which will give us xy over z. So this is what we have at the left hand side. So let's come here and do the right hand side and see what we are going to get there. On the right hand side, we have x binary y, which is in brackets. So obeying this rule of combination, I'm going to have xy, and also I have x binary z, which will also give me xz. Okay, now combining these two using the second binary there, that will give me x binary y into x binary z. So that will give me, so the second operation there is a over b, which is the first term over the second term. So that will give me xy binary xz. Okay, so that will give us xy over xz. X and s will cancel, which is equals to y over z. Now if you check the first term, the left hand side and the right hand side, we don't have the same answer. So with that, we say that since sy over z is not equals to y over z, therefore the operation does not distribute over this operation under the given set. Okay, so this is how we do distributive law. So we are done with the laws. So the next thing now is to look at the identity element and the inverse element. But before that, let us solve examples on this part of, or the laws of binary operations. So let's pick questions in probably exam questions, past question papers, and solve and see how we are going to apply what we've learned so far in solving those problems. Okay, so our first example we are going to solve says that a binary operation, this is the operation, is defined on the set of real numbers by a binary b equals to a plus b all over square root of ab, where a not equal to 0, b not equal to 0, evaluate -3 binary -1. Now, the condition here is just to make sure that this thing will give you a real number, because if we allow a or b to be equals to 0, the denominator will be equal to 0. And immediately the denominator is 0, it will be undefined. Okay, so that's why they are placing that condition there, that a and b must not be equal to 0. So solution now is very simple. This is the rule of combination. All you need to do is to put your numbers. Remember, the first number we have here is -3, and the second number we have here is -1. So therefore, -3 binary -1 will give us -3 plus -1 all over square root of -3 times -1. So that will give us -4 all over this times this will give us square root of 3. So that's your answer. You can decide to express this number in different form. Okay. So the second question we have there says that let the asterisk there be a binary operation on, this means natural numbers. Okay. So defined by a binary b equals to a minus b plus ab squared. You should find 4 binary 5. So just like the first example, all you need to do 4 binary 5 you obey your rule of combination. The first number there is A, here is 4, minus the second number is B, here is 5, plus the first number is 4 times 5 square. So that will give us these two. Okay, let's multiply first. So 4 minus 5 plus this is 25. 25 times 4 will give us 100. So that will give us, this will give us minus 1 plus 100, that's 99. So you can see how simple all these questions are. So let's look at number 3. We are going to solve probably 4 to 5 questions. So let's see if there is change in any of them. So let's progress to question number 3. Okay, so question number 3 says, let the asterisk there be a binary operation defined by A binary B equal to 4AB. Find A binary B, or in brackets binary A. So like we did in the explanation, anytime we have anything in brackets, you first of all carry that bracket in the operation given. So this time around, A binary B is equal to 4AB. Okay, that's the what we have in the bracket. Therefore, A binary B or binary A, that will give us 4. The first term is A. So in this case, the first term is the bracket. That will give us 4AB. That's what we have in the bracket, binary A. So that will give us 4 into the first term, which is 4AB, B, which in this case is what? A. Okay, so this is our first term, this is our second term. So our first term binary our second term, 4 times our first term times our second term. So that will give us 16A square B. Okay, so you can see that one looking as if it's going to be difficult, but it's still the same story, or still the same way, not just few steps and you get your answer. Let's progress to next question. So our question number 4, we have two binary operations there such that A binary B will give us A square B, and the other binary operation is 2A plus B. So we are asked to find A binary B, 2 binary 3, or in bracket binary 6 binary 7. So let us deal with our brackets, then we'll now combine with the other binary operation. So therefore, 2 binary 3 will give us, we are obeying this rule of combination of asterisks. So that will give us the first term square times the second term. So that will give us 4 times 3, which is equals to 12. Then we also have the same thing here. So 6 binary 7, that will give us 6 squared times 7, which is 36 times 7. So that will give us 252. Okay. Therefore, 2 binary 3, binary 6 binary 7, that will give us 2 binary 3 is 12, binary 6 binary 7 is 252. So obeying this rule of combination, which is this, so that will give us 2 into the first term plus the second term. So that will give us 24 plus 252. So that will give us 276. So you can see it's still the same thing that we have been doing. That's how we have gotten our answer. Let's move to example 5. Okay. So question number 5. This case, we are given the solution of our, after applying our binary operation. So we are asked to find the second term. So remember that A binary B is equals to A plus B plus 2AB. Therefore, 2 binary X is going to give you 2 plus S plus 2 times 2 times X. And the whole of this is going to give you 3. So solving this, that will give you 2 plus S plus 4X equal to 3. So these two here will give us 5x equals to 3 minus 2. So that will give us 5s equals to 1. So divide both sides by 5. 5s over 5 equals to 1 over 5. This and this will go. We have s equals to 1 over 5. Okay, so you can see as simple as that. So let's solve our last question. Let's move to a little bit more difficult question than what we have been doing. But this time around, okay, let's have the question first, then I will say something about it. Look at number 6. We are asked to show if a particular binary operation is associative under a given set. So what are we going to do? I'm not going to solve this the way I have explained before. Let me use another way of solving this problem. So I'm going to pick AB to be a number under a given set. So let me start with saying let A be, okay, let A equals to 1 and B, okay, let me use 2 and 3, B equals to 3. So I'm going to use A equals to 2 and B equals to 3. And what we mean by being associative, associative is that we need to show that A binary, B binary, C equals to A binary, B binary, C. So we need to define our C also. Let's take C as, let's take it as 4, okay? So if it's associative, no matter the number you pick, these two are going to be the same, okay? So let's call this one our left-hand side and call this one our right-hand side. Okay, so with that now, let's solve this one and obeying this rule of combination and see what we have. Then, so for the left-hand side, that will give us, let's take care of the inside bracket. B binary C will give us 3 binary 4, and 3 binary 4, obeying the rule of combination there, we have 2 into 3 into 4 minus 3 minus 4. So that will give us, this one is 6. 6 times 4 is 24 minus 7. 24 minus 7 will give us 17. Okay, then A binary, B binary, C will give us, A is 2 binary, B binary C, we have gotten that as 17. So that will give you 2 into 2, that's the first term, into 17 minus 2 minus 17. That will give us 4 times 17 times 2 is 34. 34 times 2 will give us 68 minus this and this will give us 19. So that will give us 68 minus 19. We have 9, 49. Okay, 68 minus 19 will give us 49. So the left hand side we have 49. So let's come to the right hand side. So we say for right hand side. So for the right hand side, first of all, take care of A, B, then we'll not include C. So A binary B will give us 2 binary 3. So that's 2 binary 3. That will give us, oh, we keep missing our operation, but we can continue solving that way. So that will give us 2 into 2 into 3 minus 2 minus 3. So remember, I keep obeying this rule of combination here. So that will give us this one. 2 times 2 will give us 4. 4 times 3 will give us 12 minus 12 minus 5 will give us 7. Okay. So the next thing now is to, we have gotten our AB. So the next thing is to incorporate the C. So A binary B binary C will give us, we have gotten AB as 7, binary C is 4. Okay. So that will give us 2 into 7 into 4. Okay. Minus 7 minus 4. That will give us 2 times 7, 14. 14 times 4. That will give us 56. Minus, this one will give us 11. So everything we have is 45. So since, therefore, A binary B binary C is not equals to A binary B binary C. Hence, so we can conclude, let's conclude here. Hence, the operation is not associative under the given set. Okay, so it's not associative. So you can see how we have used numbers to solve that. So you can actually use numbers to solve it, or you use algebra to solve. Or when I mean algebra, that's using alphabet to solve. Okay, so this is where we are going to end this class. Okay, we are going to continue binary operation on identity and inverse. It's a very short one. Okay, we might maybe join the two classes together so that when you watch everything at once. Okay, so see you in the next class.